Okay. So let us continue with this problem. Determine the angle theta such that an equal force is developed in legs OB and OC. What is the force in each leg if the force is directed along the axis of each leg? The force F lies in the XY plane. The supports at A, B, and C can exert forces in either direction along the attached legs. Okay, so what do we have here? We have a force F that is applied on point O, and it's doing a certain angle theta with Y, and F is in plane XY. It does not have a Z component. Okay, and we have three legs, OC, OB, and OA. Now, they are telling us that the force developed in OB and OC is the same. Okay, so here we have, let's say, a force in OB and OC, okay, and it's same magnitude. And we need to determine what will be the resulting force, what should be the force in OA, okay, in order to have equilibrium in this problem, okay. So the question is, what will be force on NOA? Here they said that along the legs I can have any direction. It can be, because the leg is not a cable, it's like a link, it's a rigid link. It can sustain compression, it can sustain tension. Okay, so here, if I do a small analysis, if we do a small analysis together, okay, already F does not have a component along Z. So the Z component some of Z component should be 0. So if I did the assumption that OC and OB are in tension, okay, then I should have OA in compression. Okay, so the force of the leg on O should be up, because if I take it down also, I will not have equilibrium in Z. Since already OB and OC, I assumed that they have downward component along Z, then OA should have a positive component along Z. Okay? And also in this way, by doing this assumption, I have I have possibility of equilibrium in along X, because I will have components that has positive X and others that have negative X. Okay, so always I do assumptions. Sometimes my assumptions might be wrong, so I will get a negative sign. Okay, so even if you assume the F downward here, if you assume the F downward, the calculation will tell you that it's wrong. You will end up with a negative result, because F cannot be downward. If F is downward and already OB and OC are downward, then I cannot have equilibrium in Z. Okay? So from the beginning, I did the assumption that the F in OA is up. Okay? So now what are my unknowns in this problem? I have three unknowns. I have first the angle theta. This is my first unknown. Second, yes, I have in each leg TOB equal TOC, but I don't know it. I have that TOB is equal to TOC unknown, and I have also TOA. So these are my three unknowns. Okay, I should find them. In order to find them, I will write the equilibrium equations. Okay, so the whole idea now is to express vector TOB, TOC, TOA, and vector F. I write the expression of all of these vectors, and I apply the three equilibrium conditions: sum of x equals 0, sum of y equals 0, and sum of z equals 0. I end up with three equations with three unknowns. Okay, so let us try to do together the expression of the forces. First, for F, it is the easiest one. F is in plane xy. it has positive x and y components. Who will give me the components of f?
It says 100
Yeah,
factor
yeah,
sine theta I
very good.
plus cosine theta j.
Exactly. Sine theta along I and plus cosine theta along j. Okay? So this is the expression of f. Now, for the force n OC, so I will put the force again for you to see. So we assume that we have TOC, TOB like this, and TOA like this. Okay? So we write that TOC vector is equal to, let us call TOC, TOB, let us call it T1. Okay, so it is T1 unit times unit vector of OC. Okay, and for TOB vector, it is equal to T1 because they have the same magnitude times unit vector of OB. And finally, for the force in OA, okay, since it's directed, we assume that it's directed from A to O. So TAO vector is equal to T2 times unit vector of OA, AO. Okay, so now in order to be able to continue, we should find the three unit vector OC, OB, and AO. So the only condition to do this is to find the coordinates of points A, B, and C. Okay? Let us look at the figure here. If you look at the figure, you can see that this circle here, this circle is in a plane, in a horizontal plane. Okay? So this means what? This means that all points of this circle will have same Z. What is the value of Z for all points? For points A, B,
0,
and C? No, it's
0,
minus 10. Look, because
minus 10.
yes, okay, because the origin is here, okay, and you have the 3 points in a horizontal plane parallel to xy, but it's parallel at a distance of 10 feet down, okay. So look, all you have to do is to find z of this point, and they will, all points will have same z. What is z of this point here? It's equal to 10 feet.
minus
Okay, so the 3 points A, B, and C will have Z equal to minus 10. Okay, now to continue with coordinates, I should find their XY components. Let us start by A. A is the easiest one. So for A is has only a Y component because look, it's projection here. So if you want, I will call this axis X prime. It's parallel to X. Okay, this is X prime and this is Y prime. So to get X and Y are equal to X prime and Y prime of the points. Okay, so I can say that X prime of A is equal to X of A is equal to what? To 0. And Y prime of A equal to Y of A equal to what? What is Y of
5.
A? 5. So the coordinates of A will be 0, 5, and minus 10. Okay. Now, what about B and C? Look, B and C might seem difficult. This is why whenever you find difficulty in a figure, look what to do. Try to draw it again in 2D. And here, this is a circle. I will draw it for you like this in 2D. Okay? I will draw it like this. This is Y prime. Okay? And this is X prime. Okay, what was the location of A? This was A. Okay, and this is from the figure. B is doing 120 degrees with Y prime axis, so B will be here. Okay, and C will be just here. Okay, so here in this figure, you can easily find the projections because as you can see, this whole angle is 180. This is 120 degrees. Okay, and this is 90. So what will be this angle here? This is 30 degrees here.
30.
Yes, this is 30. So now I can project to find the coordinates of point B. Okay, this is point B here. As you can see, B has a negative projection along x prime, because if I do the projection here, okay, it is negative along x prime and also negative along y prime. Okay, so what is the projection along x? I do cosine 30, and to take the projection along y, I do sine 30, but both are negative. So for B, what are the coordinates? For B, the coordinates are first minus 5 cosine 30 and minus 5 sine 30 along y prime and minus 10. Okay, so this is how I found the coordinates of B. And if you look back at this figure, you can also see it. Okay, this is y prime here, this is y prime, and this is x prime. So as you can see, B has a negative projection along x prime and also along y prime. Okay, now for point C, what will be the coordinates? Who will tell me? So this angle also is 30 here. Okay,
Yes.
this is also
5 cosine 30.
yes,
Minus 5 sine 30 minus 10.
exactly. So
It's symmetrical.
the only difference between C and B is that C has a positive projection along x prime. Okay, because look, it's symmetrical to B, so it will have the same x component but positive. Okay, and both will have a negative y prime component. So the coordinates of C will be plus 5 cosine 30 and minus 5 sine 30 and minus 10. Okay, so once I find the coordinates of points, it becomes a simple problem, because all you have to do now is to write 3 equations with 3 unknowns. So we will see together. So this is what they did. Okay, they found first the expression of each force, FOA, FOB, FOC, okay, and F, and then they considered the 3 equations: sum of x equals 0, sum of y equals 0, sum of z equals 0. So they end up with 3 equations with 3 unknowns. So they were able to calculate their 3 unknowns. Okay. Any question on this problem?
No question, it's just hard.
Okay, look, don't. What's your name?
Marisa.
Marissa, don't worry. The exam will not be as hard, okay? Just understand what you are doing. Don't worry. Okay?
Okay, hopefully. Thank you.
Okay.
When I tried to solve them before class, it was like a mission impossible. And oh, what is that?
Okay, but now it's not impossible. Okay?
Yes, yes.
Okay, good. Don't
Thank you,
worry,
doctor.
don't worry. I'm telling you, the exam will be very fair. Okay? I want you just to know the concept. But when you do very hard problem, you will find other much easier. Okay? Yeah, let's see you next time. Bye.
Thank you,
Thank
doctor.
you,
Bye
Bye,
bye.
doctor.
doctor. See you.
Thank you, doctor.
Bye bye.
Thank you, doctor.
Thank